In this video, we are going to look at linear functions and review some of the key features, including a deep dive into our slope. So first of all, a linear function is any function whose graph is a line. And that shouldn't be a surprise because it's right there in the title. So our formal definition is going to be, can be written as ax plus by equals c. Now, again, I should say a and b not both equal to 0. Because if they're both equal to 0, then I don't really have a line there. Now, notice here x and y are both raised to the power of 1. They are also not multiplied together, they are not divided, they are not in the denominator, there is no radical. All of those things make it not linear. So can be written as ax plus by equals c. And this is our standard form. We're going to talk more about the different forms later, but that's where we start. That's our standard form. Now, we have a couple of key features that we're going to discuss. And I'm going through this kind of fast because this should all be review. The first is our X-Intercept. Our X-Intercept is where the graph crosses the x-axis. And that is going to be where y equals 0. Because think about it, where y is 0, I haven't gone up or down any, so I'm going to be on the x-axis. Likewise, the y-intercept is where the graph crosses the y-axis. And that is going to be where x equals 0, because we wouldn't have gone left or right any. And then our third and final key feature is slope, which is our rate of change. Rate of change can be discussed for any function. Slope is specific to linear functions because the rate of change is constant. It doesn't change. So remember, our slope is rise over run, which we can also say change in y over change in x. Remember that notation from science? That delta means change in y over change in x. And our slope can be one of 4 things, one of 4 types, categories. So I'm going to draw 4 quick little graphs here. It can be positive. It can be negative. It can be 0. And it can be undefined. Now, positive slope is going to go up from left to right. So you always, forgot that I wasn't in view there. You're always going to read left to right. So positive slope is going to go up from left to right. Negative slope is going to go down from left to right. 0 slope is going to be a flat ground. And an undefined slope is going to be a vertical line. So 0 is horizontal, and undefined is vertical. It is important to note that our undefined, this is not a function. It does not pass the vertical line test. That is not a function. Okay, now we're going to dive into the slope formula, and we're just going to do a couple of examples there just to refresh our memory. So I'm going to flip to the next page. And we are going to do slope formula. Told you we were going to review a whole lot in one short little video. So our slope formula, if we are given 2 points, x1, y1, the ones are subscripts, they're small and they're down, and x2, y2. The 2's are subscripts, they're small and they're down. The 1's just mean from the first point, and the 2's mean from the second point. Our slope, which we represent with an m, lowercase m, is going to be your change in y, so we're subtracting the y's, over your change in x, so we're subtracting the x's. That's our slope formula. It's still just rise over run, but now we're doing it with 2 points. So for example, find the slope of the line that goes through 2, -8, and 1, 4. Okay, I have had students have a lot of luck by stacking their points to start with. Because then when I use my formula, I don't mix up which one is my 1 and which one is my 2. So I'm going to use my formula here. And I am going to go y2 minus y1. So 4 minus a -8 over x2 minus x1. So 1 minus 2. So my minus a negative here becomes plus a positive. So that's 12. 1 minus 2 is -1. So I get a slope of -12. So using the formula, it's just a matter of plugging the right number into the right spot and then using our order of operations. Now, I could do more examples, but I'm going to have you work through some, and then I'll help you with any that you have trouble, because I think that y'all are usually pretty good at this. I am going to look at 2 where we are counting the slope. My printer was not working so good today, so this isn't perfect, but I want to make sure that we understand that when I count my slope and I'm doing my rise over run, you don't necessarily need to write these down, but I just want to give you that visual. First of all, you're always going to choose points that are right on the grid, right where the x and the y come together, like this. So right there, where they come together. So you wouldn't want to pick, I'll show you on the next one, because this one, my lines didn't come through. So I'm going to count from here to here. So I'm going to count down 1, 2, 3, 4, down 4. And I'm going to count to the right 1, 2, 3, 4, 5, to the right 5. So my slope in this case is -4 over 5. Notice my line is going down from left to right, so we totally expected that to be negative, okay? Notice also that if I counted in the other direction, if I counted up 4 and to the left 5, I would end up with 4 over -5, and those things are equal. So I can count in either direction. Okay, second one. So what I was saying is I want to make sure I'm picking ones that are right on the grid. So this point here would not be a good point to pick, because I don't know if that's like -3.5 or -3.6. So I want to pick ones, and these are very clearly labeled for us, that are right on the grid. I always count left to right, but it really doesn't matter. I'm going to count up 1, 2, 3, and to the right 1, 2, 3, 4. So my slope here is up 3 and to the right 4. And that is it for our review of slope and some of our just basics with our linear function.